to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we're joined by Anna Filina, who is currently a software consultant at Zenika Montreal and one of the organizers behind Canada's multi-technology conference called Confu. Anna Filina, thanks for joining us.
Hi.
I would love to dive right in and talk about your close encounters with difficult-to-maintain software. First off, how would you define technical debt?
Technical debt is basically, it's not necessarily a bad thing, but I would define it as similar to normal debt. Some money that you take now so that you can have something meaningful right now, and then you pay it back later. So it's pretty similar to how you would take a mortgage on a house.
What are some common symptoms or problems that you find arise because of technical debt?
Some of the symptoms, bugs that can seem to be squashed. So the bugs, they just keep reoccurring. We fix one thing. When something unexpectedly breaks, especially if you're using some third-party vendors, for example, what happens is that you expect to be able to fix things very quickly, but then you realize that it's a lot more work than originally anticipated. And that just makes it so much harder to justify the cost of maintaining that software.
What types of decisions or maybe a lack of do you often see attributed to accruing a lot of technical debt in some of the projects you've worked on? Are you finding that there's some common patterns? Companies might take on too much debt at some point? Or is there some common?
Yes, that's rather common to just keep taking on debt without paying it back. And we see what happens in real life when we don't pay our monthly installments. The thing about debt is that it just keeps accumulating. An application becomes harder to maintain. You take even more shortcuts, which means that you'll have even more technical debt. And in the end, you have so much that you're not even sure if it's possible to salvage any of what you're dealing with. Other decisions that people are making that are strange, although I can understand the reasons behind them, people think that they can just go ahead and rewrite everything from scratch. And that pretty much never works. And there's so many reasons for that. So one of the reasons why it doesn't work to rewrite everything from scratch is because it's a lot of work and it's a lot of time, a lot of money. It's hard to justify. And while you are still rewriting this application, your business needs to run because the legacy code that you have is providing some value. So if you're not careful, you can end up with a lot of work basically that goes nowhere because by the time you're done, and because you had to maintain something on the side at the same time, you end up taking so much time to complete that project. And those projects are almost never completed.
Yeah, I've seen that a lot myself too and over the years. And I think there's like sometimes this fantasy that by declaring bankruptcy on your technical debt, that you can get a fresh start and you're not going to have technical debt the next time, or maybe not accumulate as much. And there's kind of like this fantasy that the rewrite is going to solve all your problems. But yeah, as you're going through that challenge of rewriting, maintaining an existing code base and knowing that that's going to continue to kind of deviate and change. And it's hard to merge that at some point and like make sure all the business logic doesn't get lost. And you just introduce new sets of bugs, or maybe you're able to trim out some of the fat in that process in your projects or what have you. But I haven't seen a lot of success stories there. But I'm not saying it's not possible, but it can be a little bit of a challenge. Do you believe it's possible to I think I know the answer to this, but at what point is it become obvious within a code base that there's too much technical debt? And then you touched on there's a lot of recurring bugs, but do you think there's actually a point where companies have next to zero technical debt?
I haven't seen companies without any technical debt at all because every decision introduces some sort of technical debt. Every design decision, every architecture decision, every feature that we're adding, every server that we're updating, everything is technical debt, basically. It's just a matter of how much, it's a matter of trade-off, really. How much are you getting out of it in the short term that will allow you to eventually pay it off? Because that's the whole idea. Basically, you're trying to maybe kickstart something. You're, trying to introduce a new service and you're thinking, well, maybe if I take a few shortcuts here, or maybe if I just don't worry about making it pretty from the beginning, perhaps I can monetize it and then use that money to clean it up. But if you're not using that money, you don't plan for paying it back, you're going to be in a lot of trouble.
How much do you think you're finding when you're working with different organizations that maybe say mentality or different perspectives by different developers on seeing technical debt as a good thing, bad thing, or just always a very negative thing, and like maybe dismissing some previous decisions because maybe they weren't around when those decisions were made? Sometimes I see technical debt get labeled on things that maybe that someone else had done and they would have done it differently. And so it's kind of like having to maintain someone else's code that you disagree with or something.
Yeah, I see it a lot. People come in, they have a better idea of how they could have done it. But the same is true for our own code. It's not because someone else wrote it. We can come into our own code maybe a year later. And because we now understood the problem in retrospect, it's kind of easier to, make those changes and refactor it. Now, as to, the negative perception of debt is a problem, because if people see it as an inherently bad thing, which it's not, then there is no real incentive to manage it. It's like basically this thing that has to be avoided at all costs. But if you see it as a normal part of life, you save a little bit here so that you can, as I said earlier, you can get that money and then be able to invest into something better in the future. If you don't clean it up, then you're just going to avoid that work as much as possible, because it becomes something unpleasant rather than, hey, let's just keep things clean from time to time. It doesn't have to be a bad thing.
Yeah, that's a great perspective on that. So taking a quick step back, I want to provide a little bit of background on you. Online, I've seen you describe yourself as a legacy archaeologist. How did that come about?
It was one of those days where I was digging really deep, going, class after class, and just not understanding what is going on there. Dealing with legacy is a lot about archaeology, and what you said earlier, that it's really hard to understand, what other people have written. You have to spend a lot of time going into the code and understanding what it does, because if you start rewriting things without understanding what the code really does, you're going to get bugs. And you also mentioned that. It's very easy to say, we're going to rewrite all of that. We have a rather good high-level understanding of the processes, but the devil is in the details. You descend into those classes where you don't understand what's happening. There are some weird conditions in a strange order, and maybe it's checking against things that you wouldn't think that were checked. For example, I saw a condition which I actually use in one of my slides. It's a condition that says if transaction ID is greater than a certain number, then use this SQL query to access the data. If not, use something else. I really like this example because there's no comment, there's no context. You don't understand what changed. Did we start storing things in a different manner in the database? So all of these things come to light only when we really start to dig, because code that we don't touch, we don't know what it does. And once we start rewriting things, we sort of discover all these weird things, and suddenly everything becomes a little harder. And then you go back to the drawing board and you realize that it's not going to be something that you can do in 2 months.
Sure. What's your current role at Zenika?
At Zenika, I'm a consultant. So basically, I go on different projects, sometimes very short interventions, sometimes several months at a time. And a lot of that includes dealing with legacy. So when I work on a project, I always try to refactor things as I go along and keep that technical debt under control. If there's something that I cannot do by myself, I escalate, because sometimes the organization has to make a decision somewhere. Other projects, I'm actually sometimes hired, mostly remotely. I'm hired to specifically help people create a strategy for tackling that technical debt.
And then do you have kind of like a framework? Is that something that Zenika does a lot of, or is it something that you've kind of worked on quite a bit yourself in terms of coming up with a framework or structure that you can kind of repeat that process in different organizations?
There are a lot of patterns that you see, and it's still, it requires some experience specifically with legacy code and having refactored code or having rewritten portions of the application. But a lot of that is repeatable. There are some patterns. For example, one pattern that I like to use I mean, people do like to refactor things here and there, but refactoring is not always the option because the whole structure doesn't make sense, and you cannot just put one shiny thing and it sort of magically works with the rest of the application. So the approach that I like to use, and I've used it very often, is take a specific module. So for example, right now I'm working on dealing with third-party integrations, and there's a lot of logic in, transforming these objects before they go out to send SOAP requests. So this whole portion, because I looked at it and I estimated that just refactoring it would be very complicated. So the easier approach was to actually extract that whole functionality and put it in a completely separate application. So, of course, maintaining microservices is not optimal for everyone, but, and especially because I work with PHP, that actually makes sense, because if you're going to try and integrate something into an existing application, you're going to be bound by the version that's running on the server. So you cannot go above that version, and you cannot upgrade the rest of the application because then things will start to break. Some things result in fatal errors, so you can't even catch exceptions or anything. You can't really recover from that. So putting that in a completely separate application on its own server with its own database and just calling it when you need to really allows you to sort of breathe and not have to worry about those small changes that you have to do all over the application before you even get to the place where you can start working on the thing you want to work on. And that's actually something that happened to me rather recently. I tried to make a few changes and I thought, hey, maybe we can upgrade the PHP version. Maybe we can upgrade the framework. And then I just started making those changes. And a few hours in, I realized, well, that's not going to work out because there's just too much stuff to do. Might as well just let it go and take just the portion that you want, rewrite it properly, and then link the rest of the application to it. And that way you can slowly extract these parts, because don't forget, by the time you finish extracting everything, the first portion is already going to be probably obsolete, because it takes, some large application, it takes a while. I've seen applications go to the point where, like a big ERP, the language that it was using has been discontinued for 10 years at the time it was called.
Oh, wow. Do you think there's a point in like a good balance between how much you break up a larger application into a lot of microservices where it can become like maybe a different sort of problem on the other side of that, where maybe you have too many microservices? Have you seen that become a problem at all? Or have you found it's just like maybe a handful or kind of might be optimal?
So I attended this interesting presentation, I think in Berlin a while back, that said basically that you shouldn't use microservices unless you have the infrastructure to maintain them, or, the right people as well. So no, I don't preach splitting everything into microservices just because it's the cool thing to do. It really comes from a decision, not for the fad, but really because you need that piece of code rewritten. There's nothing you can do but rewrite this single piece, but there's no way to extract that. I mean, the other possibility is you can start with rewriting a portion of it, and then you can keep adding the new features to that new application. And that's something I've helped a client do as well. They had this web application, and they needed to go away from this other language that, as I said, was unsupported for 10 years. And it needs to be moved to something newer, so something that is maintained. So we started creating a separate application and just did some tricks to forward the relevant URLs, the URLs that were rewritten, to the new application, so that the user experience was still seamless, but you sort of jump between applications, and the only thing binding you are the cookies, right? Because you need to maintain the sessions. But you're here jumping from one application to the other, and the idea was to slowly migrate things and deprecate them in the other application as they were being moved. So it doesn't have to be a whole bunch of small applications, just the ones that make sense.
Yeah, one of the things that some people that I've talked to about microservices, at least an approach that, you mentioned infrastructure and making sure the team's set up for that, is also thinking about who owns what areas of the infrastructure, like from the software perspective. And do you have like just one big development team or maybe a small development team that's responsible for all of these things? And how do you decide which microservices are going to be responsible for what, and like who's responsible for maintenance on those specific things, and are you introducing new technologies into those microservices as well? And so I think there's a lot of decisions that can go into that, and it's an interesting approach to try to simplify things. But then I've also seen some of the complexities where you've got like 8 to 10 microservices, and you're like having to roll out, let's say, like a change for one microservice, knowing that if you make a change here, you got to have to sync up your deployments so that they can kind of roll out at the same time, or come up with a plan for releasing new functionality.
The thing about microservices actually is that they have to be isolated enough from the rest so that you wouldn't have to roll out the rest. That's a bit the point of a microservice. You can have a completely separate team responsible for that. I've worked with a bank that was pretty heavy on microservices, but I mean, they call them microservices, but they're really separate applications because they have completely different concerns and they communicate with each other. And that was done quite effectively, but of course they had a big team for that. But then you can have one application that's in one language and another application that's in a different language. And then you have those teams, that are fluent in those languages to maintain them. So another client had a PHP team and a Java team. So they built completely separate things that talk to each other rather frequently. So that worked well. You touched a good point when you said you need people who know the language. So what do we do about that? Usually what I do is if somebody else is going to maintain that, then I have to make sure if they don't have people who are fluent in the language, I have to make sure that they have the proper training in order to be able to maintain that in the future. Usually the steps are strategy first. So we think about what makes sense in the short and long term as well, how they're going to maintain it, say 5-10 years from now. Because those applications, they live for a very long time. Because a lot of them are pretty useful, right? So these companies will just keep using them until forever, I guess. We have to have a plan, on how to transition that, and not just this time, but maybe the next time as well. So how we're gonna maintain that. So the first part is the strategy. The second part is usually give people the training they need for the kinds of new languages they're going to be using. If they've never done object-oriented programming, maybe we need to help them with that. And also a bit of a follow-up. So to make sure that once they start in that direction, that they keep going in the right direction and they don't fall back on their old ways.
Some accountability from an external source, or is it something you're able to kind of help instill within the organization themselves?
Yeah.
When it comes to, you talk about your process there, and when you come in and working with different types of clients, do you have any stories about, in terms of maybe a really difficult scenario, where have you come into an environment and felt like the issues were less software specific and more personnel, the team itself or process?
Yeah. Usually in the larger organizations where it's not as obvious to make a decision. Yeah, a lot of the legacy was there because of, office politics and all sorts of decisions that I couldn't even get a clear answer on why those decisions were made or by whom. And maybe those people have been long gone, and maybe those people keep doing the things they're doing because that was the directive at the time. Dealing with people is, I would say, not in terms of technical debt as much, because technical debt is just about some education, a little bit of help, and most people are pretty happy. They're pretty happy when you show them how to do things properly. Yeah, the human factor comes in more when we talk about project success, what makes a project not go as fast as we'd like.
Yeah, have you got a good sense of, when you've been working with different, injecting yourself into an existing development team, the processes that you've seen that you've helped either implement, or processes that you've seen them implement that have been, you think, rather helpful to providing a good long-term, stable, and maintainable code base?
I would like to think so. So for example, some people, they have trouble making the code testable. So they need to make decisions, do they make it work through some mocking voodoo or something? Or do they want instead to change the design of the application a bit to make it more testable? But yeah, people are usually they pay attention to what other people tell them. If it's proposed in a with a lot of tact, depending on how you propose that, people, they incorporate those ideas in their daily lives pretty quickly, and I've seen some really good results.
That's great. What advice might you, let's say, if people listening that maybe they're an engineer working at a company and they're one of, say, a team of 50 developers, give or take, spread around the country or spread around the world, maybe they have a distributed team. What advice might you give to an engineer working at an organization like that, where they might be feeling that their concerns about technical debt or long-term maintainability of the company's software is not being heard by stakeholders or people that are setting priorities? What kind of advice might you provide them to start making a difference?
Yeah, well, there are two things. So there is, of course, the human factor. That's where the human factor would play. You need to convince people to get on board with you. You have to go around and make allies for your cause. Because if you are the only one who is going to refactor anything or improve things or try to remove that technical debt, you can be the only one for a very long time. Because trying to do everything by yourself, especially a team of 50, well, first of all, it doesn't mean that everybody will just magically follow you. And the other thing, they might even undo what you've done because it just doesn't fit with the rest, and not because they're of any malicious intent. They'll just keep doing things the way they've always done them. You don't necessarily need to convince people on top before you can start using some best practices. You can just start cleaning things up by yourself. I forgot who told me that, but the approach to legacy is if you touch it, you have to refactor it a bit.
Make it better than it was when you encountered it? Yeah.
A bit like when you go, hiking in the mountains, you want to pick up the garbage if there is any, instead of throwing your own away. So the idea is to clean things up a little bit in the legacy if you can. At the same time, try to convince people to join your cause and maybe train them, maybe do some lunch and learn. And hopefully if you can convince somebody to get some training, maybe go to a conference and learn a few things that can help with managing all that technical debt, that could be very helpful. And I know in some areas there's actually a law that you have to provide a certain amount of training to your employees, so that can fall into that category. And there are pretty good talks at conferences. So I've just came from a conference recently, and I only had a chance to attend 3 talks, and already I feel so much better. I started refactoring something and I was already better than I was before. There's a lot of interesting information there for everyone. It's probably the easiest way to get into this whole business, because when you read a book, it's one thing, but if you can talk to somebody, ask questions, that's a lot more interesting. You can share specific concerns with people.
Yeah, you can get that little spark of energy, or just think about the problem a little differently after having spoken with someone or listened to a podcast or what have you. And that can kind of at least motivate you a little bit to think, oh, I can go back and I can start taking care of these small things. It's, you mentioned like, you don't need to convince people to start improving things. And I think that's sometimes often overlooked by a lot of people, where like one of the things that I've encountered myself in my career of working with different companies, because we kind of work on existing code bases as well. We'll come in and we'll talk with some developers, and maybe they're like the second or third wave of people that worked on the software. And they're like, well, these problems have been around for 5 years and it didn't seem like it was important to management to deal with it then. And I just kept working and following the same patterns. Or, yeah, I asked about, hey, when can we prioritize doing this upgrade? Or we need to refactor this area of the code base, or this area is really brittle. And they said, maybe not right now, maybe later. But they translate that to no. And they stop asking and thinking that it's just not a priority. But I think one of the things that I guess when I talk with my own software development team is just thinking about, like, you don't need to ask the client for permission to act in their best interest. But as you were saying, when you go into an area of code, clean up the area of, that code in there. If you see some stuff that looks a little messy or needs to be cleaned up, or needs maybe some documentation because you figured it out because it's not obvious by looking at the code itself, you can do these kind of like little micro improvements. And that is a good practice just overall. And then hopefully other people can get some buy-in for other people to follow that best practice. But you don't often need to like ask permission to clean up things. No one's ever, unless you have competing, priorities for some other reason, like, well, if we need to get some other feature done by today, maybe it's not always the best day I'm going to go start refactoring at the last minute. But I think that is part of I think the responsibility of a developer is to remember that they also need to that's like their area. That's their area of like being in control of. And the product decision makers are probably a few tiers away from that. They just expect you to be taking care of that stuff, right? I think to some degree.
Yeah.
And so.
Yeah, and some people, they have this perception of being micromanaged. Although it does happen, there's this perception that every little thing that they do, they have to sort of justify. So, for example, a good example is unit tests or any sort of automated tests. People would say, well, we don't have time for this and we will never be able to convince management to do unit tests. But if you start looking at these things as an integral part of your work, then you don't have to convince anyone to do that. You don't have to ask permission. So, for example, if I'm going to draw a little diagram to help me understand some process in the application or try to understand the flow in some service in there, I don't need to ask permission to doodle in my notebook, right?
No, that's a good point.
Yeah. So the same thing is valid when you start cleaning up code. I mean, this is just normal. You're not going to ask for permission to rename a variable. You're not going to ask permission to extract a method so that things are a little more readable. Ask permission to add to encapsulate some functionality in a collaborator because you feel that your God class has way too many responsibilities. It's the small things.
It's true.
And they add up.
With regards to like automated testing and writing unit tests or whatever approach you're taking with testing, it's like my question with people because it comes up like I didn't have time to work on tests, and I'm like, well, how do you know it works? And just kind of leave that being an open question. And they're like, well, I tested it. And I'm like, well, how did you test it? And you're like, well, I maybe did that in code, or I tested the interface and it did what I expected. I'm like, great. That's like, you did technically test it, but you could probably I think it's usually often the testing is not baked into their general workflow enough that it becomes second nature. Like they can approach it like, oh, how am I going to test this is like the first question when they're working on this. Like, how am I going to verify this is working? And like kind of the afterthought is like, well, I'll figure this out in your browser, reloading pages and clicking on things and seeing if it does what you expect it to. It's usually more of, I think, a training and just getting confidence level up. But I don't think a lot of people are saying, don't write tests. Like nobody wants 0 tests in a code. Like I can't imagine any business owner saying, no, I don't want you to test the code. But they expect you to.
I heard someone say that that's the reply they got. And I'm not sure why they're still working there. There's probably better places to work. It's not like we developers don't have a choice today.
That's true.
So yeah, just let them be without tests. And the thing about automated tests, I really like this subject as well. So you say, okay, you went to the browser and you tested things, but that means that you have to create the UI, you have to create all the components, and you have to wire them together before you can start testing anything. So that's the first thing. So just today I wrote a few services, and without having to touch the browser even once, I was able to ensure that all of that works correctly and that the exceptions are being thrown correctly. All the edge cases, which are actually not so easy to reproduce. And the way to reproduce them is to go into the code and like maybe at the top of the method override some properties, but basically you're doing a setup. Might as well just write the test. It's the same thing. And the time you're going to spend testing that to the browser, as I usually talk about manual testing, the number of times you're going to have to repeat that test is very quickly eclipsed by just writing a unit test in the first place. And of course, I find that there's a strong correlation between technical debt and having unit tests. Because first of all, as you said, how can you guarantee that there are no bugs? There are probably lots of bugs. And every time I come to a project where there are no unit tests, I find that immediately as I start unit testing it, I find that there are unreachable statements, things like that. So in PHP, you can even find places where you're calling methods that don't exist because PHP doesn't automatically detect that. Usually when I open these projects, I start filing bugs pretty quickly because once you start unit testing, you really dig deep. And the other thing is, if you want to get rid of technical debt, how are you going to do that if you don't have any tests, how are you going to refactor things? How are you going to rewrite? You're not even sure exactly how it works. You're going to have to read the code and understand that from scratch. With different levels of automated tests, that's a little more feasible. And actually, one thing I would advise people who are thinking about going into a project that has absolutely no tests and start unit testing everything. Just a little word of advice. If you plan to rewrite a lot of those things, or if you're going to change your classes, everything, then perhaps unit testing is not the right approach in the beginning. Perhaps higher level tests, such as functional tests, will ensure that you maintain the same functionality, but then under the hood, you can start moving the pieces around with less risk. And then those new classes that you're going to create, then go ahead and write unit tests for them.
So in terms of, I'm sure you have a lot of, different experiences over the years. And in terms of software development processes that you've encountered, like which two do you believe are most valuable to the long-term maintainability of an organization's code base? I'm assuming there's not not every company has a way to automate reminding you to take care of technical debt. So are there strategies and team dynamics or and processes that an organization might put in place to remind themselves that they have to deal with these things that have been maybe accumulating for a few years, but maybe they're not paying attention to?
Well, I'm pretty sure developers are reminding them all the time. One thing that's interesting is to see how many times does the fixing on one bug introduce additional bugs. That probably shows you that you need some sort of automated test to catch those regressions. I mean, there are just so many things. Pretty much everything will remind them at some point. It will stare them in the face, They'll see them very often just by how long it takes to do absolutely anything, how many vulnerabilities they might still have. Yeah, I don't quite know where to start.
Sure. So 2 last questions for you. What book do you find yourself recommending to software developers most often?
I really like the book Effective Management of Legacy Software by Michael Feathers. I find it basically captures the experience that I had very nicely. So I really enjoyed that book. A little less, I would say, it's not as technical as some other books where they show you the specific techniques, like very, I would say, code level techniques. So I like the approach in that book.
Nice.
Yeah, that's a pretty good book.
So let's talk about tools for a moment. What are some of your suggestions for developers who might not, say, appreciate the full value of some of those tools? And what tools do you find yourself often recommending people level up on either their knowledge of or start experimenting with?
I was for a very long time reluctant to use an IDE, but I was convinced otherwise, and I've never looked back. I would say an IDE is probably the most essential tool, like a proper IDE, that has all the refactoring tools, that inspects, it has some static analysis for your code that's going to show all the different potential problems that you might have that you may not even find out on your own. Especially if people are using just manual testing, that can catch a lot of interesting bugs, and also performance issues, security issues. And also I like to configure everything inside my IDE so I don't have to leave it. So I use PHP a lot. So I always configure the step debugger. I just cannot live without it. I would say take the time to configure it properly, pay that IDE license. It's really worth it because it just makes my life so much easier. I couldn't see myself dealing with that kind of legacy code without those tools.
Interesting. And what IDE in particular do you use most often?
For PHP, I use PHP Storm.
Okay.
Not in any way affiliated with them.
And where can people follow you or learn more about the type of work? And I know you speak at a lot of conferences and such, but where can they follow you online?
Online, so I tweet. So at @Filina, that's my Twitter handler. I also have, I started, and I should publish some more videos there. I have a YouTube channel where my plan is to eventually fill it up with short tutorials that are pretty practical, but at the same time give you some insight into the more theoretical aspects of things. So just a bunch of best practices.
That sounds great. Yeah, that's actually how I first came across you, was watching one of your videos. So thanks for that.
Oh, cool.
Well, thanks again for joining us today, Anna.
Thank you. It was a pleasure.
Thanks again.
Have a good day.